This project began as a plan to review the Ruckus R700 enterprise-grade access point, a $1,000 AC wireless access point, as a standalone AP and then compare it against a reasonable cross-section of other AC access points, including Ubiquiti's and Meraki's MR18. I had this gigantor spreadsheet where I was going to put all the data and everything, and then I took a step back and realized I was tackling too much at once. The first thing I need to establish before I start evaluating, which business grade Wi-Fi gear is best from an enthusiast perspective is whether enthusiasts should care about this product category at all, or if they should keep spending all their money on graphics cards. So that's what's coming in this video. Oh, and coming soon is our review of the Logitech G910 RGB mechanical keyboard, but first, the intro. From December 13th to 20th, 2014, you can save on select Intel CPUs, NUCs, and SSDs with special holiday rebates from select retailers. Click now to learn more. So where would I get the idea that any individual consumer might want to spend this much on an access point? Ruckus thought it was stupid and refused to even loan me one to do this kind of a test, but I really wanted to try it, so I actually bought one to do this video. I was inspired by an awesome article that I read on WLANpros.com while researching solutions to my ongoing issues with periodic hiccups in NVIDIA Game Stream and HD movie streaming to my media center. In the article, they investigated the performance of a variety of high-end APs in a classroom environment. And while the nuts and bolts of the results, which model won which tests, etc., have lost some of their relevance since there are newer products released now, the realization that I had while reading it was that most router tests are basically being done in a vacuum, so to speak. To control variables, a perfectly reasonable thing to do, many reviewers will pair a single client to the access point, measure the speed, and then if we're lucky, they'll do it again from a few different distances so we can get some idea of how that performance scales over an area. But this doesn't address what kind of performance you can expect when multiple clients are running intensive tasks concurrently, something that can happen easily in the real world if you've got a few family members with their own mobile devices in your home. So, I designed my tests, and I can already see, having finished the data now, that they've got some issues, but it's a start, with the intention of determining not only the performance at various ranges of a high-end router with an integrated access point, like a consumer-grade thing, versus a top-of-the-range business AC access point, but also the performance at a fixed range when there are many other clients across the network putting load on it. So I'll start with the range data. The range on the R700 is truly exceptional. Inside the house and even in the front yard, speeds were less or similar to what my Linksys WRT 1900 AC could achieve, using the average of a 30-second 3-stream iPerf run at each location. But once I got across the street in front of the house, it was 30% faster, and then when I walked down to my mailbox, a total distance of about 120 feet with the neighbor's house directly between my Droid Turbo and the access point, it was still able to achieve acceptable sustained speeds for web browsing and even light media streaming. Next, we'll look at our 4 scenarios that I used to evaluate performance with other clients using the network. In the light test, every access point config I tried worked fine, but we can already see performance of the iPerf test fall off a little bit, especially on the WRT, just from having Google Play Music, a 2750 kilobit Twitch stream running at source quality, and a PC refreshing a basic web page every 3 seconds, running to simulate what it might be like when a few family members are on their phones or computers on an average evening. In the medium load test, I add a second video stream running on the same PC that's doing our internet browsing test. It's a 20 megabit 1080p video, the kind that many people download to a NAS and then watch from a computer. There were no interruptions to any of the devices in the medium test either in any config. In the heavy load test, we add another 2750 Twitch stream, and a 20 megabit 720p NVIDIA game stream, and this is where the men get separated from the boys. With game stream, decent throughput is necessary, but latency is of paramount importance because the user is interacting with a remote PC in real time. In our case, an MSI gaming notebook. This was the last test where the R700 achieved perfect performance at 2.4 gigahertz before running the stress test, and once the stress test got turned on, it turned to crap with one of the Twitch streams being interrupted and gaming on the Shield becoming impossible. So that is something to bear in mind as you look at the throughput numbers in these tests. If running the stress test causes other clients to stop working, then it's not a representation of how much the network can handle on top of what it's already doing. At 5 gigahertz, the R700 handled this flawlessly, even completing the stress test with only occasional choppiness in the game stream test, but the same cannot be said for the WRT. Not only did it put up much worse numbers during the stress test, but before the test even started, on 5 gigahertz, one of the PC video streams failed outright and game stream was hitching periodically. Which leads us to the torture test, where we found that we could reach the limits of the R700 by throwing another laptop running a 1080p YouTube video and a 50 megabit 1080p network video stream and an NVIDIA Shield portable running a 3000 kilobit per second video stream. And even then, it actually has performed reasonably well. Now, I did manage to get this 50 megabit stream to glitch out a little bit earlier in the day, but now everything is running flawlessly, even with the torture test. So that means we are pretty much at the limit. Now, when I run the test itself, for the throughput, when I run the throughput test, Tomb Raider will chop, and then this video will definitely turn off. But overall, a very impressive job is being done by the R700 of managing this workload. Another cool thing to note is that even with all this running, if you run a speed test on another computer, completely unrelated somewhere else in the house, but connected wirelessly, you can still get like 7 millisecond ping times to nearby servers, which is about what I can do on a wired connection. So just something here will suffer, but it does a great job of managing all of that. The WRT was a total mess in this test though, so I'm reporting 14 megabit for the iPerf test, but it's a completely meaningless number. I mean, even without iPerf running, both PC video streams cut out, the YouTube stream cut out, and game stream was completely unusable. Only the Twitch streams managed to hold together. So, closing thoughts time. Do high-end access points make sense for enthusiast consumers? Honestly, I think the answer is mostly no, not really. I mean, anyone with a large house, like 2,500 square feet or more and multiple stories, who doesn't want to deal with slow range extenders or multiple access points and then the lousy connections sometimes and handoff issues that are associated with that, may actually benefit from one of these. But they are paying a lot for features that they'll never use, like the ability to add a dedicated controller somewhere else in the house and more access points to build a managed array of access points. For most people, adding additional consumer APs on different channels and then switching between them manually, especially on 5 gigahertz where there are so many channels available, will be much more economical, and as long as the clients are more spread out than they were in our torture test, higher performance overall anyway, since you can spread out to many more of those available channels. So I don't think I'll be following this up with more standalone high-end AP videos unless you guys feel like it's really necessary, but I'm still glad I did this video. I learned a lot, and in spite of some frustration, it was kind of fun too. I hope you guys enjoyed it as much as I did. Speaking of things you might enjoy, it's the holiday season, and our sponsor for today's video wants you to have an Aorus X7 Pro gaming notebook for Christmas. I mean, okay, they're not giving it away or anything, but if you're in the market for a beast, super thin gaming machine now, or maybe right after the holidays with your Christmas money, it is definitely worth a look. It's got top of the range specs, including a Core i7 quad core and dual 970Ms in SLI, the performance of which we checked out in our showdown a little while back, which you can check out here. Thanks Gigabyte for sponsoring today's episode. Thanks to you guys for watching. And I think that's pretty much it, guys. Like this video if you liked it. Dislike it if you disliked it. Leave a comment letting me know what you thought about this video, because it was it was a bit of a beast to put together. Thanks again for, oh right, also linked in the video description, there's a support us link. You can buy a cool t-shirt like this one, give us a monthly contribution, or change your Amazon bookmark to one with our affiliate code, so when you go buy that Aorus X7 Pro notebook, we get a kickback. It helps us out a lot. Thanks again for watching, and as always, don't forget to subscribe.